Here are our next ones, starting with sine. You ready for this? Here's the sine graph, here's the tangent. As I drag it along, it will plot all of the slopes. See my slope is 0 up here? See that all my slopes are now negative. They're all negative, negative slopes, negative slopes, negative slopes until we get back to 0. And they're positive again. Oh my goodness. That's crazy. Isn't that crazy? It just made another nice curve. What do you think the graph of that curve is? It's cos. The derivative of sine is cos. And one thing that I actually if we refresh here, I find this video thing really actually helpful for understanding. Can you see that at 0, if you drew the tangent, it has a positive slope? It's going to be a positive number, okay? And as I move it all along from here to here, all of those slopes are positive. Can you see that the blue graph in between those points is all positive? Until it gets to the maximum, in which case it's flat. It's 0. Then this section's all negative until here. Now, different steepnesses. This is the steepest point of the negative. Then it starts to flatten out again. So that's why it has that rounded back to 0 place. And we get cos. Okay. Cosine graph. Notice that it starts flat. And you see that between 0 and pi, all of the tangents are going to be negative. Oh my goodness. What equation would be the best way to describe the blue equation? It's a negative sine graph. And if I just taught you the rule that derivative of sine was cos and derivative of cos is negative sine, guaranteed you're going to mess up and sometimes mix up which one's negative and which one's positive. Or at least you're going to ask yourself, ooh, is this one positive or is this one negative? How am I going to remember? I think by looking at the graphs, especially, let's look at the cosine one. I'll refresh it here. You can see that you're starting at 0 and then going downhill right away, going negative right away. I use this idea of, I imagine my tangent on my cos graph, and I imagine it going negative right away. That really helps me remember that the derivative of cos is the negative sine graph. But if you start it on your sine graph and do the derivative, you're positive right away and you're going up. It's going to be a positive cos graph. Now, the not so easy one. Tangent. All right. Maybe that gives you some ideas. It's not a parabola. Why? Because it repeats itself there, and repeats itself there, and over and over and over again. This part, if it's not a parabola, what does it remind you of the most? It seems to have asymptotes, and it seems to look like this. Ooh, to this graph. What's the green graph? The dotted one? That's cosine graph. If the green graph is the cosine graph, what kind of graph made asymptotes at x-intercepts? The blue graph here is the secant graph, the reciprocal of the sine graph, 1 over cos graph. Now our graph for tangent has that same shape, but what could we mathematically do to not have the second one on the bottom? What could you mathematically do to this graph that would, there's two things I can think of. Two things that would make this part positive. Absolute value is 1. That's what I thought you'd think of first, and it's not the right one. The right one, another thing that makes this positive. Squaring it. And so the derivative of the tangent graph is secant squared. Which I think is pretty cool because remember in identities you had this identity, tan squared plus 1 equals secant squared. And so you have one place that tan squared and secant squared are already related to each other. And now they're related to each other in a second way. The derivative of tan is secant squared. And again, I'm going to tell you these derivatives of e to the x natural log, sine, cos, and tan, they're on your formula sheet, but you will not have enough time on an exam to look at them. You need to just, you need to think. You see sine, derivative is cos. You see cos, derivative is negative sine. You see tan, derivative is secant squared. And now we can start mixing and matching everything we've learned up till now. Could you figure out the derivative of 4 sine of x? Well, just like with e to the x and just like with different polynomials, that 4 in the front doesn't make a difference. It just stays there. The derivative of sine is cosine. So the derivative of 4 sine x would be 4 cos x. Here we have cos, we have tan, and we have a 3x cubed. First of all, do the 3x cubed derivative in your head for me. Got it? Got the derivative of the 3x cubed? So the derivative of cos is negative sine, and the derivative of tan is secant squared. So the negative will make this positive 1/3 sine x plus secant squared x. And then I hope you got the 9x squared. Very, very nice. Uh-oh. We can do the derivative of sine, but we do not have a rule if sine is on the bottom. So this is a problem. We also do not have, we have a derivative for sine. We do not have a derivative for sine 2 theta. So unless it matches up perfectly with the derivative rule, do not make up your own derivative rules. That ends up badly, usually. So we have to manipulate this. Does anyone see anything we could do to manipulate this?
Like the double angle identity?
Yeah, the double angle identity. That's equal to 2 sine theta cos theta. Okay, is that helpful in any way? Sometimes you see something, you try it, and it actually ends up being not helpful. But sometimes you see something, you try it, and then you see something else. So you just, That's problem solving in math. Like, what do I know? I don't know if this is going to go anywhere. I can tell you sometimes you try things for a very long time and get nowhere. And then you have to go back to the beginning and say, I better try something else. But in this case, it works out nice, because what can you do? Yeah. Oh. Which changes our equation. And now it's in a form that we can do. Derivative of cos is negative sine. So we get negative 2 sine theta. Okay. Try this one on your own, and this is where we will end for today, leaving us waiting to find out what rule number 5 will be. Okay, let's see how you did. Did you find derivative of cos? At x equals 0, cos of 0 is 1, so that's the slope of our tangent. We have 0, 0 as our point. We can plug it in. You just get y equals x. For our normal, the slope would be negative 1. Plug it in, you get y equals negative x. There's a little picture. Is that what you were communicating? Okay. I heard some new sign language going on. Awesome.